Hello and welcome back to my channel, and today is again new technical aspects. I hope you see now NXP behind me, and back to more technical covering of boards. Of course, the application from NXP is in front of me, and I am happy to talk to different manufacturers and companies who are building and developing boards using NXP. And yeah, looks like in front of me I can see the company Phytec and also the company Vertium. So looks like they are active in autonomous driving. So
Hey, how's it going? I think I saw you in the other presentation. I'm done by the way.
So where can I start? I will as usual, I will just make a small coverage of what is happening here, and then I will specialize with talking deeply with each and every company, right? So let me first take a look at what they are here. So again, more boards, delicious food, and even some sweets. All right, I can see here a chair from NXP, right? Of course, is everything connected to the board. Of course, I will be trying this chair before later, but let me first scan the environment here, and then coming by the Digi, which is like very interesting, of course, and the Swiss company Robotics. It has also a lot of very interesting boards here. So looks like there are a lot to cover here, guys. I hope you stay with me till the end, and I promise you will get a lot of interesting information here. So I found also some LCDs. And info chips, right? Let me see what they are here having. Hi. Would you like to tell us a little bit about the company? What are you covering today?
So Arrow is a hello everyone. Arrow is a big distributor, so we sell NXP products. So we are giving away some evaluation board today.
Oh, that's very interesting. So you are more or less distributor, yeah? So people who wanted to build projects, they can come via you.
Yeah, they can definitely talk to us. We can help them finding the right parts. And not only that, we can give them the samples, evaluation boards, any help they need, from the concept to the production, we can help them out.
Okay, so basically, do you get some of the money, or how much does it work financially? So if a company would like to open a new, develop a new project, they get in contact with you, and then do you guys sign a contract, or how does it work?
So the way it works, once they sign, talk to us, we have an NDA signed, mutual non-disclosure agreement, and then we go forward. We try to find out what they're designing, what kind of help they need, what kind of engineering resources they have. Then we can support them based on their needs, And eventually, when they go to the production, then Arrow can supply the parts to them,
And can you tell us who would be your customers? So maybe previously...
Everybody and everybody.
All right, anybody who is interested into digital...
Anybody doing electronics components, they're our customers,
All right.
Thank you.
Amazing, thank you so much, appreciate that. would you like to tell us maybe a little bit about Green Hill software? So I know that you guys are building operating systems.
Yeah, operating systems, development tools, compilers, debuggers, partition kernels for safety and security, deeply embedded operating systems. We do it all at Green Hills.
So what is different between your operating system and Linux?
Well, ours would be much smaller and faster, more real time, and it has security and safety certifications already achieved that don't have to be added onto with other layers like Linux would. It just gets too big.
Oh, that's interesting. And does the companies just simply download your operating system, or do you have to sign a contract?
You would need to use a license agreement and sign it, but you would talk to your local Green Hills office and understand if it's the right fit for you. And if it is, then things could proceed. If not, then they don't.
That's interesting. And do you build also some projects or just only the operating system? I will give you an example. In my previous company, we wanted to integrate 6 different cameras on the same board.
Right.
So would these projects would be something that you guys can help us to do?
Not typically. The consulting we usually do is to get our operating systems and tools running optimally on a given platform, and then the customer does the application from there. There might be partners that deliver middleware that could help too.
All right, that's interesting. And do you have any, either any industry that often use your operating system, for example, automotive or aerospace, or is it open for everybody?
Well, Green Hills has been around for over 40 years, so all of the industries have used us to some degree, all of the verticals. We're very big in aerospace, avionics, very big in automotive because of the safety and security, and then all kinds of different verticals, storage, deeply embedded controllers.
Interesting. I can see here some demos. Would you like to take us a little bit deeper in the technical aspects? How does it work? I can see here some boards. So these board covers is working with your operating system.
We have our integrity operating system running on the MX95, and the microvelocity operating system is providing a safety island on the MCU. I forget the number of the MCU part.
All right. Okay, and people just...
And then these are all our products, the IDE development tools, shows you exactly what's happening on all the processors over time.
So is it what the software developers will be seeing in the screen when they open?
Yeah, software developers would use the screen as a way to visualize what's happening and then make modifications and improvements, enhancements, optimizations, things.
And let's imagine if they wanted to write a like the software program in C++. Does they add their files here in this side?
There's a different window for that, but yeah, it's a visual environment. They would add their files in. Yeah, this is a visualization of these are different cores or different CPUs on the board.
Okay, that's interesting.
And that's what's happening on the CPUs on the board.
Okay, and can I use any IDE, for example, Visual Studio Code?
We use this one. We build the whole thing.
Okay, so everything is going to be here, and then
everything. So it runs the same on Linux or Windows. It looks identical.
Oh yeah, that's interesting. And how do I compile my code? So I wrote Hello World program. How can I compile it?
Yeah, we provide the compiler, linker, everything. So you just use our environment, build the code, download it, and run it in the operating system.
Okay, that's very interesting.
It's a very complete, well-integrated environment.
Okay, and is it any kind of boards, or is it only NXP boards, like microcontroller?
Well, since I'm here today, it's NXP.
Makes sense, yeah.
And others.
All right, but of course others. Okay. Any ARM, like ARM processor?
Yeah, ARM. RISC-V, even
RISC-V
MIPS.
also.
Okay. Hitachi, SH. We support all kinds of stuff. It's on the website. People can go there.
All right. So I will write, of course, the websites in the description below. Thank you so much for this wonderful information.
Thank you.
Right. And for the people who are interested, I will of course write the name of the website. Of course, the company is solving a bottleneck in development in order to perform a fast and secure projects. This is something that can be solved from the operating system itself. So, yeah. Let's see what else do we have here. Oh, we started very early. I wanted to show, I think, this is for the automotive, I think. Hi, would you like to tell us a little bit about your company? Okay, no problem, thank you. Well, I see a lot of interesting stuff here. Oh, let's try this here. Let me see. So here you see the chairs. I'm not sure if it is like for the aerospace or for a race. Yeah, I think it's for autonomous driving. That's very interesting. That's super interesting. And here I can see some camera.
None of them has really any extra hardware cost.
I think it's machine learning running on the chip. Hello, hi. Would you like maybe to tell us a little bit about the demo? What does it do?
Yeah, so we have our.
Maybe you can hold it.
So we have our
So firstly, you are from the company MC A1.
I'm Robert McKeon, I'm from NXP.
Yeah, oh yeah, you are from NXP.
Yeah.
All right, nice, okay.
So you want me just to start talking?
Sorry?
I just start talking.
Yeah.
So this is our ARA240. This is our ARA240. It's a discrete neural processor. So it's from a company we acquired, Canara. So it's a discrete NPU processor that can do large language models, and this demo here we're showing a very large language model, and we're basically showing you can take a video and capture that video, and then you can process the video, and then you can ask it questions and it'll describe what's going on here. So it's a very high performance processor for doing AI.
Interesting. And what can we see here? VLM Edge Studio. Is it like a virtual?
It's a very large language model.
Okay.
So it's doing like AI processing.
Oh, that's interesting. And does it run on the CPU itself?
No, this is a dedicated accelerator. So you can see here on the back we have a M.2 module. So the M.2 module has the ARA2 discrete NPU. So it has its own dedicated DDR, so it's a high performance interface. interface.
All right. And what? So what? Oh yeah. So maybe I can do. Can I write to the model here?
Yeah, so what you can do is you can activate the video. So then it's just going to start recording, do a quick, video capture of what's going on.
Okay.
So then I'll process the video and feed it into the model. And then you can ask a question, tell it what's going on.
Now can I write, ask a question or what?
Yeah, well, I've just asked it a question, so it's going to come back and tell me what it is, but it's just processing the result right now, so then it's going to tell you what it sees.
All right. Oh, that's brilliant. That's very interesting. Colorful design. So the video depicts a scene where two individuals are engaged in a conversation in what appears to be a public and semi-public space, possible and mounted on stabilizing a device. It's talking about my camera. And I wanted to see if it will show that I was counting with my hand. The background shows other people, some of whom are also holding cameras. Wow, okay, that's
so
interesting.
then you can ask her a question if you want as well.
So what, let's say, let me ask a question. How many fingers?
What does the VLM stand for?
Very large model.
Very large language model.
How many fingers was?
So it's kind of like ChatGPT, it's large language models.
I asked her how many fingers was raised, so even the question is not very clear, but I hope the very large language model will understand what I was thinking of. Basically, I think ChatGPT reached to the level of really understanding, so let's see if this will understand. So the image shows two individuals, one holding a camera and the other holding a microphone. The person with the camera is wearing a white shirt. Okay.
Yeah, I mean, I think the question's more about like describing what's going on. It doesn't really like specifics. So
but it's very interesting that everything is now happening. Okay, but again, is the model running in the processor itself?
Yeah.
All right.
No, I mean running in the offload. Running in this one.
Okay.
So the model running in that.
Yeah. All right. Oh, that's very interesting. And is it also part of your demo, or it is?
Well, this is just another example. So this example here is just running a CNN type application. So we have 8 simultaneous video streams, and it's just showing you that the ARA 2 can do processing of multiple models simultaneously. So you have 8 video streams, and it's doing the object recognition and object detection and so on. And then the i.MX 95 is using the video capabilities of EPU just to display the videos on screen.
Oh, that's very interesting, because now you can find that it's not only recognize one video, but six different videos or 8 different videos at the same time.
Right, and it's not just recognizing one object in the video, it's multiple objects as well.
Inside even the tie, I can see here the tie, yeah, and the cow, zebra, here car, and it gives even the percentage of discovering. So here I can see as well a keyboard, 80%, mouse, a cup of coffee. That's very interesting. All right, so these can be used, of course, more into security detection and other application.
Right.
And avoiding the privacy of having the module running on cloud and
so
sending our
so that's where NXP is focusing, is the edge AI applications. So you have latency, you have privacy, and then you have cost, because then you don't have to use the cloud infrastructure as well.
Very cool. And is there also something else, or is that?
You speak to this guy, he can tell you.
All right. Robert, thank you so much for this information. It was very interesting. and I have already worked with NXP before, and then I can recommend it. I worked with i.MX 6, very old, and I think i.MX 93 now is the future.
Okay,
Thank you so
you.
much, Robert. Thanks.
Sorry, you're
My channel called Dali Technology in YouTube. Dali Technology. All right, but I will come back to tell you about it. All right. Thanks. All right. So that was interesting. Let me see who would have the time for me.
Coordinated drone shows are using UWB, two-way communication between them to make sure they don't crash into each other. So I'm hoping.
I'm pretty fine. Would you like to tell us a little bit about the device here? Is it something that's used at home to unlock doors?
Okay, yes. That is a very simple access system. A very simple access system that goes ultra wideband that measure the distance and the angle where I'm located. So if I'm outdoor, if I'm close to my house, it's unlock my door. But if I go inside, they detect me and they close the door.
Sorry, can you repeat again what happened just now?
I'm outside of my house.
Right.
Okay? So when I'm, for example, right now, I'm away from home.
Right.
Far away from home. And now, what I'm doing here, no, go ahead, Cookie. What I'm doing here is I approach it to my house, open my door, get in, and then close the door.
Very easy.
Simple.
No need for keys now.
Exactly, that's the point.
That's interesting. But so the first thing that come to mind of anybody who think about that is how about if it make an error or like let's
It's hackable?
yeah, could be hackable or
No.
okay.
No, why? Because of the protocol they're using is a ultra wideband. That's make very smart and very short message in the less than a Bluetooth devices. Okay, so that gives you less chance to hackable, but also it's less opportunity to make an interference like a body, for example, or path. There's the reflection from the path system. That's another point. Maybe you don't need a line of sight because also they know in which angle I'm located. If I'm coming from left or coming from right, they know exactly where am I. See?
So it looks like it has a LiDAR system.
Kind of, but no.
Okay.
If the LiDAR is going to RF, very high frequency, this is going very low frequency, like a 900 megahertz.
Oh, yeah.
But due to the protocol that goes very fast on the transmission and reception, I know where it's located. And the location is between, I'm using two antennas to know exactly, triangulate the position of the anchor of my key.
That's very interesting, and I can see an application in, for example, public places in which you wanted people with membership to enter and the other not. For example, fitness or hotel or whatever. So can you have a look for only 1 day, 2 days, whatever? Is it programmable?
I put in a more big picture. Hospitals.
Or hospitals, yeah.
That when I'm a nurse, I cannot allow it to go to surgery. If not, it's not my shift. I only have the allowing to check patients, or the people who only have the maintenance, only have some certain areas, or doctors only have access, or even at the guest. I'm not relative with the patients. I just have enters the room and have allow it. But also these guys detect me if there's not one floor. If I go moving to the next floor, they know me in real time if I'm on the second floor, third floor, fifth floor, 10th floor, or in the basement.
Amazing. And where are you guys located?
Here in the US, we're located in San Jose, We have an office in Atlanta, and we have another office in Texas, Dallas.
So let's imagine if I'm a hospital and I'm interested in to make my doors with you.
Exactly.
Yeah, okay. How can I start it? So do we just send an email to you and then you guys
Go
send
to
somebody?
murata.com, send an email, and we'll be glad to assist you.
Amazing. Thank you so much for this awesome product, and it is really something that's very interesting. This is the future,
Yes.
and I hope to next time I don't need to get a physical key and worry about forgetting it.
It's not only for physical key. For example, location of the robots in a warehouse or the pallet driver. That's another one. Location of your luggage in the airport. You know, that's kind of solutions I can think about it.
All right. So multiple application, and I can see it also in the future for cars, I think.
Yeah, unfortunately, this is not allowed right now, but this is not automotive certification. This is not right now. Yeah, so you have no solution to automotive certification, but yeah, could be used.
All right. Appreciate that. Thank you so much,
Thank you.
Ruben, and I wish you a wonderful day. Thank you.
Okay, thank you.
Dali TikTok in YouTube. Dali TikTok, right?
Can you?
Yeah. So. So that was very interesting information about the technology of future doors, I would say. I am pretty sure that in the future it will be also mixed with AI. And so this is more or less like physical AI, I would call it like that. So it's like something that take part in our daily life, facilitate our daily life. So I will write the name of the company and the website in the description below. And I hope people will also get in contact with the guys here. They are very friendly, and maybe you can make your door smart, right? So that was something very interesting. All right, so looks like thank you so much. Which company? Like in Q&A. Yeah. So I like here the vibe that is like next to each other are very valuable technologies. They are very different aspects. But again, one of different is also I found a very interesting company. Oh, I think I know the company. It's located in Germany. Tell me yes. Yes.
Yes, based in Munich.
Yeah. Actually, I studied in Technical University of Munich. And I was trying to do my master thesis with you, Lauterbach. Yeah, Lauterbach. Very interesting company. I think it's more or less for debugging.
Yes, debugging and trace.
Yeah. So see, this is the hardware ecosystem. You're gonna be meeting like the advanced technology everywhere, right? That's very interesting. So maybe you can tell us a little bit about the company or tell the audience about what is the recent step in your company.
So we're Lauterbach. We've been in business for almost 49 years. We're the premier debugger and trace solution on the market. All the major companies that have any type of high-end processing use our debuggers. We have a debugger as well as trace. So if you have a bug in your software that's happening and you can't use like a breakpoint because it'll mask the error, we can actually trace out what's happening in the code, and they can come back and replay it to find exactly like maybe a symbol was off or a variable wasn't where it was supposed to be, and then that enables you to get down in deep and debug things in a very quick and efficient manner.
Okay, so does it debug FPGAs or it's
Yes.
more, okay.
FPGAs, microcontrollers, microprocessors.
Okay. And is the trace, so let's imagine a developer. So I worked after my degree, I worked in a company which built 3D laser scanners. So that device was very complex. And actually, one of the points that you are mentioning was really a bottleneck. We didn't know from where is the problem. Is it hardware? Is it the software? So we wanted to trace what is happening in the hardware itself.
Correct.
So how should the developer integrate your system into their, it's more or less microcontroller, right?
Right. So, well, the first thing is we interface with the debugging through the JTAG, and if you're doing trace, you have to bring out a few extra signals to trace exactly what the processor is actually doing. And so the processor on the back end spits out all the information about what it's actually doing, and then you can record that, and then you can go back and look at everything. So the trace module here is what enables you. So we can, basically trace up to 8 gigabytes of data in code, and then you can go back and retrace it.
Okay, so I can see here a record, a running, and select. So do you record certain scenarios? Or
It records signals coming out of the microprocessor and variables, so you can basically record all the data and then go back and analyze it later and look at the functions, how long the functions took to run, where all the variables or register settings are at in those points. So it's a really high-end debug solution.
That's interesting. And I see here the software. I think this is where the developers will be using in order to track and to log information.
Correct.
Can I imagine?
Correct.
So, so here, is it the architecture level or what? Is it assembly level, really?
Here is the trace packet that we received here. We perform decoding on the host here. So we have the trace between two time here, and we can move. We can find bugs here.
Very interesting. So I can see here is a C++ code.
Yeah.
And this is, I can imagine, is an assembly of it.
Assembly, yeah. You can debug assembly. You can debug HLL. We offer plenty of mode here, debug mode. Some people are more familiar with assembly. Some people are more familiar with C++. Yeah, we offer plenty of.
Okay, so it's more or less debugging, all right? So this is, I would call it more or less like a physical debug, I would say. So not only, and this is actually, this was one of the bottleneck that I as a developer have faced. It's like you write a code and then you are not sure what is happening under the hood in the hardware itself.
That's exactly right. That's it, and it enables you to go and look under the hood and see what's happening to get a better debug scenario.
Oh, okay. That's interesting. And you guys are located in Munich. Munich is a wonderful city.
We're based in Munich, but we are personally located in Vancouver, Washington, and we have another office in Detroit and in Boston.
All right. I'm very happy that the company is now is all over the world.
Yeah.
So Lauterbach, yeah, very interesting company, wonderful people. I'm pretty sure that is very needed to debug. I personally have faced a lot of problem debugging the device, and I think your solution can save a lot of time and efforts, and again, time is money, right?
That's right. That's the whole key.
All right.
Being able to solve your problem early saves your engineering time, saves your schedule, keeps your everything online. And once you learn how to use the tool, you can take this same tool and use it on next projects and keep learning. We also have a whole scripting mechanism to where, like, once you have to change things, you can just add it to your script, and then you boot up, you hit one button, and it gets you exactly to the same debugging state that you were at before.
All right, Robert and Ahmed, thank you so much for all of this information.
Thank you so much.
I will write information about the company below in the description, so make sure to follow, visit their website to get in contact with these people. Thank you so much again.
Thank you, brother.
I will come back, right? All right, that was very interesting. Meeting again somebody who I have met before in Germany. Here, they are more or less for debugging, and debugging is something that is really cool. Because like sometimes you don't know where is the problem, right? You stay a lot of time trying to figure out what is the source of the problem. So I can imagine like building devices just to debug and focus and detect where the problem comes from and show and trace the problems I think this is something that it is very, very interesting. All right. So far I get to know a lot of cool experience. And all right.
We're a little late.
Hi. Would you like? Are you busy now? Can I? All right. Okay. Maybe I can later. So Phytec is a very interesting company. I think I have to come back here, but there are other applications. I think it's more or less for safety. That's very interesting. Hi. Would you guys like to tell us maybe a little bit about the product here? It's Variscite.
We are from Variscite.
You are from Variscite.
Yeah. Variscite is a company that manufactures system modules. We manufacture a lot of different system modules based on the i.MX processors. We have in-house manufacturing. We are based at Israel. We have our own factories, and we manufacture different modules. We have different families with different processors, but they're all pin-to-pin compatible. So we won't have to redesign your carrier board if you want to switch the processors.
Okay. Interesting. So this is the microcontroller, and it's all the PCB is all built, or the board is all built by you and various.
Yeah, that's right.
Okay, and it looks like there are a variety of different boards here.
Yes, a different board for different modules. Here we have a list of the modules we have. They are all pin-to-pin compatible. So if you design for this chip and you want to exchange the processor, you won't have to redesign your carrier board because they are all compatible.
Oh, right. Okay, yeah. That's interesting. And what does every board? So let's first maybe go for the VAR MX91. So what kind of communication protocols have connection? That does have any? So can I connect?
Yeah.
I2C, SPI.
Yeah. All
cameras,
of that. Have dual camera, have Ethernet, Wi-Fi, I2C, SPI, WART, everything.
Okay, so I just connected it. And how about generating a firmware? So if I wanted to build a device and I wanted to build a Yocto firmware for it, can I really? Do I have the manuals to follow in order to generate Yocto?
Yeah, sure. We have the manual in our developer center site, and we provide all of it as open source, so you can access our GitHub. You have all the Yocto recipes available, everything.
Okay.
So you have just to follow our guides, and you can have everything set up.
Okay, that's very interesting. And is it a live demo, or is it a video, or is it really
No, it's a live demo.
Oh, that's very interesting. So it's a machine learning model that's running here. Oh yeah, that's very cool. So I like that it has also LTE. You said it just has LTE system.
LTE.
It's I think it's more or less with data. So yeah, you mentioned that it has a Wi-Fi.
Yeah.
But some other companies, they wanted to they put a SIM card inside their device so that they can connect to internet without the need of connecting to a Wi-Fi. So something like in your mobile phone. So LTE system. But But yeah, but if it is not have, I think it's not really
No, I
not,
don't. Yeah, no.
not really needed in every company. And here is a PCI system. Is it like smart arc? I think.
No, it's like our own design.
Okay, that's interesting.
Yeah.
Okay. And I can see here two Ethernets connected here.
Yeah, both Ethernet connectors, USB, USB-C, SATA.
All right. And GPIOs, the pins here.
Yeah. GPIOs, wired, everything.
All right, that's interesting. And how do you? I think it must be written somewhere here. The frequency and how fast is it has, like 1.8 gigahertz.
Yeah. It depends on which processor, but we have a whole different processors, like with a multi-core, single core. It depends on the kind of application you want to do, but you have this information here as well.
Okay, that's very interesting. All right, so that's very interesting. I think where are you guys located?
Variscite is located in Israel.
Nice.
Our office is there. Our factories are there too.
Okay.
But we have the thing is all around the world. We have I'm from Brazil. We have people in Italy, Germany, here in the US, all around the world.
Okay. All right. So thank you so much, Ali, for this information.
Okay, thank you very much. Nice to meet you.
Nice to meet you.
Thank you.
Thank you. All right. All right. Hi. Here we go. Yeah. I already worked with Phytec before.
Oh, you have?
Yeah, I have. We will more or less for prototyping.
For what?
So more or less first before development. So trying out to generate a Yocto build, Yocto Linux system from it.
Yeah.
I think it's located in Germany.
Yes.
And I really like the support that you guys offer.
Yeah.
For your people.
Yep.
And I would like to learn more. What is the recent onboard computer that you guys are offering?
Yeah, so there's a lot that we've been coming out with. I think there's some, millimeter an MCU, the RT1170, which is our smallest SOM on the market right now. It's 30 by 30 millimeters. It's an MCU crossover. So meaning it just has a little bit more power than some of the MCUs out there, but many of our customers and medical and industrial settings will use that. Beyond the RT, we also have a new solderable technology coming out called the 5-Flex.
Okay.
Yeah, so the 5-Flex enables someone to be able to scale their processors. So let's say we have NXP's i.MX 9 series. So maybe someone uses an i.MX 9.1 or the 9.3. And the idea is that you can use a 5-Flex to maybe start or have a product that has several different features. Maybe start with a lower level, like an i.MX 9.1, and then if you want to scale it to something has more features, then you could scale it all the way to an i.MX 9.5 without having to redesign the whole carrier board.
That's actually very interesting because I have an experience working with a product that the company was building its own device using i.MX 6.
Yeah.
And then they wanted to evolve to i.MX 8.
Yeah.
Right. And this is a very big headache from the onboard computer manufacturer because they offer a completely new onboard computer that even the hardware, like the BCP, has to change. Mm-hmm. And in some point you have to start from scratch. So solving this problem, I think you'll solve a lot of headache for a lot of developers.
Yeah, that's what we hope for. And it's solderable too. So that gives a lot of different types of benefits as well. Yeah.
That's
so,
interesting.
Thank you.
And I personally has tried to follow the Yocto tutorial that you guys
Yeah.
are offering in the internet.
Yeah.
I find that very helpful, and then I also motivate everybody who wants to generate a Yocto image to go follow the Phytec. They offer very interesting
Yeah.
tutorial. Yeah, but how about if somebody wanted to build a product with AI? So do you offer any boards that
Yeah.
can run tiny machine learning in it?
Yeah, many of these processors that we're using from NXP, like the i.MX 8 Plus or the i.MX 9.5, has those AI capabilities. Our goal is to get that SOM as small as possible with the most pinouts as possible, so folks can use the full features of that processor. So, and a lot of AI work can be done on that.
All right, that's very interesting. Yeah, fair enough. So how about if a company wanted to build a small project? Do you support something like that? So for example, I worked in a project before, and the company wanted to connect 6 cameras in the same onboard computers. So can they? Yeah, do you offer this service or?
Yeah, most of the processors are not going to have that kind of capability that we have. It's more of like an industrial. But say it is some sort of an industrial camera where maybe they want 4 different lanes or 4 different cameras wanting to see it, like in a setting where security setting, that kind of a thing. Then people might use one of these type processors, like the 8 Plus or like the 9.5. But yeah.
All right. Appreciate it. Thank you so much for this interesting. I felt very happy seeing the company again, Phytec. I covered the company in Nuremberg in Germany last Embedded World 2025,
Yeah.
and I'm happy to see more and more progress here. So Phytec is everywhere: Germany, USA,
Yeah.
and
France,
yeah.
and India.
Oh, wow,
yeah,
okay.
China, yep, all of it.
That's
So,
very cool.
yeah.
Nice.
All right. Thank you.
Richard, thank you so much.
Yeah, thank you. Nice to meet you.
Yeah, I use a board.
Were you using
It
like
was-
are you an engineer engineering firm or like
I used to be firmware developer. Yeah.
okay.
So we were building like 3D laser scanner.
okay.
So it was
got
like we, as I told you, we were like using a we were like prototyping more or less.
Okay, yeah.
So that's I don't know. I can't remember the name of the board, but it was it was i.MX 8, I think.
Okay.
Something like that. Yeah.
Oh, okay. Got it. Yeah. Very cool.
So yeah, I am on YouTube called Dali Technology, but I will come back to you.
Okay.
Maybe we have small talk.
Okay, sounds good.
Very good. Thank you.
Yeah, nice to meet you.
I meet you too. All right, that was again very interesting. Covering. Oh, the suite is about to go. Oh, that's very sad. I would like to try it, but no time. Only Our suite is technical conversations, I think, and that is very very cool. And Biggie was also very interesting. I would like to go speak with them, man. So. I would like to see this robot arm, right?
It was good. Yesterday was really good. Yesterday was pretty busy. What do you? Took us a while to get there. Yeah. So what are you thinking? Like, is this fun? Yeah.
So it looks like here is a rover. I feel like a small micro rover and robot arm. And NTC sensor. What is NTC sensor? That's interesting. software-defined factory. Hi. Would you like to tell us a little bit? I can imagine it's something that is working in automotive industry. Is that correct?
Yes, it's automotive electric vehicle architecture.
All right. So you can hold it. I have mine here. All right. So I can see here the wheels starts to run. We're about to go. Interesting. So is the motors connected to the board, or what? Can you please tell us a little bit about the demo here?
Yeah, absolutely. So this demo is all about consolidation X-in-1. In a typical electric vehicle architecture, you have several individual ECU boxes. In this, we're talking about consolidating them in various ways into single boxes. So in this instance, we have what's called a 5-in-1 e-axle. And this is kind of based around the traction inverter, DC-DC, onboard charger, and so on. And then you have the BMS controller, thermal, and VCU separate. Now, in another flavor, you have the battery management unit based, where the BMS controller is here. You still have DC-DC, but OBC and traction inverter then sit outside. In some cases, you move all the way up into what's called 8-in-1, where all of the vehicle functions that we saw separately are now together in one. Now, when this happens, complexity of the system goes up quite a bit, and because of that, you have to have a very good safety isolation strategy. We're talking about safety critical systems with ASIL ratings from B all the way up to D. And so freedom of interference and safe isolation is very important for safe vehicle operation. In one example, we show some type of external event, whereas you get something happening on the traction inverter system, maybe a high voltage event. The system detects that, right? And then that application in particular goes into what's called the safe state, basically shuts down, does some recovery mechanism, and then after some certain amount of time, comes back up. Now, what's important here is that the other systems are still functioning just fine. One fault in the system didn't cause the whole system to go down. So that is one example of how a system would operate when having a fault with this type of X-in-1 platform. Now, over here we're showing our different evaluation platforms for enablement. We have our traction inverter board. It's the analog front end. We have our analog DC-DC board. We have battery management board here. And then here is what's called the motherboard, showing our current generation K39 device daughter board sitting on top of it. Now, this device in particular will enable you to do up to 3-in-1, but our next generation device, K5, would allow you to do something more complex like up to 8-in-1.
Oh, that's very interesting. And is it already in the market? So are there already electric cars that already use your system?
Yeah, absolutely, absolutely.
All right, that's very interesting. And actually, it solves the problem of having a complex car in which it's like a lot of everything is automated. So you feel in some point insecure if some of the system fails, then the whole system will fail. So having such a complex system that can detect a failure, this I think it is. You guys are really solving a bottleneck.
Yeah, absolutely.
Yeah, that's very interesting. And so X-in-1 modules. So who decide how many modules can be added?
The vehicle manufacturer.
Okay.
Right? So it really depends on a lot of things. A big driver is the safety strategy. In some cases, it makes more sense to have certain vehicle functions together. Maybe there's a legacy system that groups functions in a certain way. Maybe a particular manufacturer has a certain idea about how they do their safety decomposition. So there is no one solution fits all. It's really a matter of what the specification is.
All right. Sounds really amazing. So So Adam, would you like to tell us which modules do you think is essential for any car? I can imagine the power management is essential. What else do you think?
Yeah, I mean, certainly power management. You have your e-axle drivetrain, right? Lots of motor control related functionality, charging, DC-DC systems, to name a few.
All right, you have already named six or seven different modules, and that is very interesting. Cool. And maybe you can tell us a little bit about the hardware level. So integrating the systems together. So they are like different systems that are separated. So how can you integrate them from the hardware perspective together in order to build one complex system?
Yeah, so really what that comes down to, and I'll pull this up again, what that really comes down to is how you decide to isolate your application. So each one of these applications will translate to certain sets of hardware, right? Each will have memory requirements, each will have a certain number of cycles required on the core to do its algorithms, each will have certain peripheral I/O that it needs. And so the way that you bring all of the separate systems together is that you clearly identify the requirements of each application, and then you assign those to the core. And so we actually offer something called our Flex Foundation software. It's a tool that does this exact thing for you, right?
That's interesting.
On the left, you have your available resources, all the things we just discussed. And then here you can create what we're calling domains. So each domain here would map to maybe one of the software applications that we talked about, traction inverter, BMS, thermal management, etc. And then you would essentially drag and drop the memory, I/O, peripheral requirements for each one. And then to get the isolation, you would have certain policies that dictate what can and can't be done by a particular domain.
All right. I appreciate that from you. Wonderful information. Thank you so much, Adam, for all of this information. I'm really very happy that you guys are trying to solve a problem that would bring safety to our cars in the future. And I hope that people would read more about your technology and getting more engaged.
Thanks for your time.
Thank you so much. All right, I'm called Dali Technology in YouTube.
Okay.
All right, take care, man.
Hey, brother.
Hey, man, how it going, man?
Good to see you.
Yeah, you give me a second, I will come back to you. All right, so far it has been an amazing covering for a lot of applications, and I will try to cover more. But thank you so much if you reach it to this point. There will be another video covering more and more about the technical aspects today. So stay in touch and see you next time.